Hello everyone, I am ATUL NEGI and I welcome you all to this IMS Academy YouTube platform. So we have started our Theory of Machine Foundation course and this is the last lecture of the Flywheel topic, right? We have discussed the basic fundamental part first of all, and then we have solved previous year gate questions also, right? We have discussed about the purpose of using Flywheel and how it is different with respect to governor, right? We have seen the usage of the governor also and the usage of Flywheel also. And what is the basic reason for which we are using Flywheel and what actually it is controlling. Every aspect of the Flywheel topic we have covered in this lectures, right? So if you have not watched till now the complete basic fundamental parts, please go back and see the complete playlist of Theory of Machine Foundation course, right? So in the playlist Theory of Machine, you will be getting all the lectures which we have covered till now. So this is the lecture number 17, guys. Till now total 16 lectures we have covered. This is the lecture number 17. And today we are going to end our Flywheel topic. And after that we are going to start with the gears topic, where the first lecture will be on the gear classification and then gear train part, which is very important for the gate examination. Right, so let's get started here. So in today's session, we'll be discussing some of the PYQ question and one special topic of Flywheel we are going to discuss, that is the punching. How we can use this Flywheel in the punching machines, how to analyze the Flywheel which is used in the punching machines. All those things we are going to discuss, and also we will solve some questions from the punching machines, right? So we'll start the session. But before starting the session, guys, please do join this particular Telegram group where you will be getting all latest job notifications, and daily quizzes will be there where you can prepare for your competitive examinations, right? Apart from that, all the YouTube schedules you will be getting here, whatever we are doing in the IMS Academy YouTube channel, and all lecture PDF. Till now 16 lectures I've covered in Theory of Machine, right? All lecture PDF you will get in this particular Telegram group. So please join this Telegram group. Link is already provided in the description. Okay. And I already shared many times this information, guys. We have started our IMS Academy live online program, right? So this is the right time to start preparing for the gate examination, right? So this is the ideal time, because if you join after 2-3 months, then definitely you will have a less time for the preparation. So this is the right time for which you should start preparing for the gate examination. In this IMS Academy live online program, more than 800 hours of sessions will be there, which is totally interactive. Apart from that, you will getting GQB book, gate question bank, exercise book, where you can practice the problems. Okay, because in the gate examination, mostly student need is what the question practice material. So already we have designed that exercise book based on the different difficulty levels, level 1, level 2, level 3, like that. So kindly join this sessions, this particular online program for your gate preparation. Apart from that, 12 mentorship sessions you will be getting here, right? So everyone, if you are interested here in this live online program, you can directly call on this number to start your preparation in the gate examination. Okay, so starting with the topic, okay, Flywheel we are starting, and before going to the some theoretical concepts here, we will first discuss this gate previous year question, right? Till now almost all questions we have done. This was the last question that we need to discuss here in the Flywheel topic. Now in this particular question, if you read here, they have given the torque and angular speed data. Torque and angular speed data. So this is the angular speed diagram with respect to crank angle. This is the torque value with respect to crank angle. So this information is provided. Now they are asking the moment of inertia of the Flywheel. Again and again you will see in many questions they have asked about the moment of inertia of the Flywheel. In order to find out the moment of inertia of the Flywheel, what is required? Delta E, because delta E, fluctuation of energy, will connect the moment of inertia relation. Okay, so what was the formula we are having? Just see everyone. Delta E equals to I, that is mass moment of inertia of Flywheel, omega square average into Cs. So this is the formula we are having. So you will be able to use this formula when we have the delta E value, then easily we can solve this mass moment of inertia value. How to get this delta E value? Delta E value is the excess energy that is what stored in the Flywheel. Now excess energy, how we can understand from this turning moment diagram? whatever the energy is available above the mean torque, that will be considered as excess energy, right? So first of all, from this torque diagram, T theta diagram, can we find out the mean torque? Is it possible? So if it is possible, so calculate the mean torque, because whatever the mean torque will be there, above that whatever the area is there, that will be considered as delta E, excess energy, right? So let us see everyone how we will do it. Okay. So first of all, this part you should understand that mean torque, okay, lot of time, okay, work done per cycle divided by the time period. So we have seen lot of problems where we have used this relation, right? Work done per cycle divided by time period. Okay, work done per cycle divided by time period. Now work done per cycle can be written as area under T theta diagram. Area under T theta diagram, right? Time period. This is what the formula of mean torque. Now area under T theta diagram we can easily calculate from here, because torque variation with respect to theta it is given. So area under T theta diagram. Now please understand everyone. So this is the diagram we are having. So first of all, 3000 into pi minus pi by 2. This will be under plus sign and this one will be in negative. Okay. So here it will be 3000 multiplied by pi minus pi by 2. Then minus 1500, because it is already mentioned minus 1500 torque. Okay. Multiplied by 2 pi minus pi. Divided by time period. Time period in this case will be 2 pi, right? Because after 2 pi the cycle is going to repeat. Now from here you can easily calculate the mean torque value, right? So if you have understood how to calculate the mean torque value, then it is very easy. Okay, it is very easy to calculate what the delta E, because whatever the delta E is there, it is the excess energy available above the mean torque value. Is it clear? Okay, fine. Now coming to the next part, guys, very important. So after this calculation, okay, if you do the calculation, the mean torque value, you will get what? See, 2 pi minus pi, it will be pi only. Okay, if you take the pi minus pi by 2, again minus pi by 2 will be there. So 3000 divided by 2, 1500. So finally if you solve here, you will get 0 value. Now the point here is the mean torque will be the 0. So here this is what the excess energy. So this part will be what the delta E. Now this is what a delta E value. That delta E value I will utilize here. Okay, everyone. That delta E value I am going to utilize. See, delta E value is what? See, 3000 multiplied by pi minus pi by 2. Okay, 3000 pi minus pi by 2 it is there. Okay, mass moment of inertia we need to calculate. Now omega average square. Now from this diagram, omega maximum value and omega minimum value we can easily identify. Okay, we can easily identify the maximum and minimum value. So this is what the omega maximum. This is omega max and this is omega mean. Okay, 10 radian per second omega mean and omega max is 20. So just take the values here, 20 plus 10. So that will be the average multiply square, omega average square. CS value, okay. Now CS value how you will find out, because CS formula, we already know the CS formula, that max minus minimum value divided by omega average. So from here you can easily get the value of CS also. So omega max is 20 minus 10 divided by omega average. 20 plus 10, 30. Okay, 30 divided by 2, it will be 15. So from here you will get the answer here, 10 divided by 15. So this will be our CS value. Is it clear, everyone? So omega max 20, omega mean 10, minimum omega is 10. So 20 minus 10, 10 will be there. Average 20 plus 10, that is 30 divided by 2, that is 15. So we'll get the answer accordingly. So 10 by 15 will be the CS value, which you will put here. Okay, the value you have to put it here, CS. So finally from here you will get the answer of mass moment of inertia very easily. Okay. Hi Shubham. Okay, so please calculate and tell me your answer about the mass moment of inertia of the flywheel. Do the calculation and tell me your answer. Everyone, please do it the calculation part and tell me your answers. Right, another way of approaching this particular problem, see everyone, another way how we can solve this one is this delta E value. Right, how to write this delta E value? E max minus E mean, that is I omega max square minus half omega mean square. Right, clear? Like this also we can write delta E value, so there is no problem. Okay, from here also I will get the value of delta E. That delta E value I will put in the formula. Okay, so this delta E value is also written as like this, I m omega square, like this. Is it clear, everyone? Is it clear? So we have done like this, right? So if you follow this approach, you can easily solve the problem, right? It is very easy. So point here is we need to understand first of all how to calculate the mean torque value. Work done per cycle divided by time period. Work done per cycle is area under T theta diagram, right? And time period after which cycle will again repeat. So if you follow this approach, you will get very easily the answer. Is it clear, everyone? Done? So that was the question which was asked in this GATE examination 2014. Now finally the answer I will mention here is it is approximately 31.4. Okay, so answer that we are getting here is 31.4 kg meter square. That is what the answer we are having. Okay, is it clear? So you can check the answer. Please go through with the calculation part and please check it. Okay, you can cross check the data also. Now next very important part, guys, see. Now I hope you remember when we have written this T theta diagram for the 4-stroke. Right, T theta diagram we have drawn for the 4-stroke, right? Now let us again just draw this diagram. Like this. So pi, this is 2 pi, this is 3 pi, and this is 4 pi. Pi, 2 pi, 3 pi, and 4 pi. Okay. Now here you need to understand that we have also mentioned the mean torque value, that is the minimum torque. Okay, mean torque, basically we should say mean torque. Mean torque is that torque which is required to just overcome the load on the engine, right? Mean resisting torque also we can say. Now if actual torque is more than the mean torque value or the mean resisting torque value, in that case what will happen? Engine is going to accelerate. Engine is going to accelerate if the mean resisting torque value is less compared to the actual torque. Okay, actual torque is more than the mean resisting torque. So whatever torque we are developing, it is more than the required value. So obviously engine is going to accelerate. Now if the actual torque value is less compared to the mean resisting torque value, in that case what will happen? Retardation. In that case what is going to happen? The retardation is going to happen, right? Okay. So write it like this, case first. Okay, so this information is also very important. So everyone please note it down. If actual torque is greater than the mean torque, in that case what is going to happen? This actual torque, okay, this is the case of acceleration. Okay, so in that acceleration they might ask you calculate the angular acceleration. So what you will do? So you need to do just simply take the difference of actual torque and the mean torque, take the difference, and that difference will be equals to I alpha, mass moment of inertia into alpha. Actual torque minus the mean resisting torque, take the difference, that will be equals to I alpha, right? So from here you can easily calculate this angular acceleration value very easily. So that is the case number 1. Now consider case number 2. Where actual torque is less compared to mean resisting torque. So what is going to happen? Retardation. Right? Retardation. Now please understand here, in that case this mean torque minus actual torque, if you take the difference it will be equals to I mass moment of inertia multiplied by alpha. Is that clear? So in this case alpha value will give you what? Retardation. It will give you the retardation answer. Okay. So please understand, if the mean torque value is what? The required value so that engine can run smoothly. Now if the actual value is more than that, acceleration happens. If it is less than that, obviously retardation is going to happen, and accordingly we can calculate angular acceleration and retardation value. Both the values we can easily calculate, right, using these two relations. Is that clear? So that is also the another important concept which is required. You might have this kind of questions in your upcoming GATE examination. So chances are there that from this topic also they might ask a question. Definitely chances are there. So that's why understanding of a concept is what very, very important. Okay, it's not just that we have just solved previous year questions only and from that only questions will again repeat. No, it's not like that. We have to give something little bit more extra efforts we have to give. If you really want to score a very good marks in the GATE examination, you have to give little bit more efforts. So preparing the content and then solving PYQ, that is the necessary, but not sufficient to score a very good rank. So what is required? You need to understand that we have to solve more and more different variety of questions. Okay, then only our learning will enhance. Okay, then only we will learn the topic in more detailed manner. Right? Now coming to the next topic, guys, that is we will discuss about the punching. Right, so here we will discuss about the punching. So let me just draw the mechanism here. Consider this as a tool we are having. Okay, this is the tool we are having. This is the workpiece. Okay, let's suppose this workpiece having a thickness T. Thickness T it is there, and this tool moves from here to here. So it is considered as a stroke length of the tool basically. Stroke length. Okay, that is called as stroke length. Is it clear everyone? So this is the stroke length. So this is the tool we are having, and that tool is going to do a punching on this particular workpiece having a thickness T. Now it will start its journey from here and it will end here. Okay, and then again it will return. So in this, when it is moving from here to here, the punching operation will complete it, and then again it will return, and in that return it is not going to perform any kind of work, right? So punching happens when the tool moves from this position to this position and then again return back to its original position. Now while going from here to here and again from here to here, how much angle the crank is going to rotate? 360 degree, complete rotation you will see. Okay, that is 2 pi angle rotation will be there. Is it clear? But when actual punching happens, there will be some crank angle theta 1 and just punching over crank angle theta 2 will be there. That will be there. Okay, that is the possibility. Okay, now very important point, total punching operation will be completed in some time. That time will be known as cycle time. Cycle time is the time which is what required to just cut a one hole, which is required for punching a whole layer. Simple. Okay, please understand this point. Starting from here, then coming to this position, then again return back. This is what a complete one cycle. So in order to punch one hole, whatever the time is required, it is called as cycle time. Okay, that is known as cycle time. And actual punching time will be different. Actual punching happens here only, na? When I talk about actual punching, in that case I am not concerned about how much distance it is moving apart from punching. That is not the concerned part. When I say the actual punching happens, it will be taking only small time. But when I say cycle time, it takes complete motion of the tool also. From here to here and from here to again come back to the original position. Is it clear? Right? Now, so that's why cycle time is what very important here. Cycle time will use TC as a notation. So cycle time will be there. Let's suppose something, the time required for tool to move from here to here and from here to here. Cycle time TC. In that, whatever the rotation will be there in the crank rotation will be crank rotation will be 2 pi or 360 degree. Fine. Okay. Is it clear? Fine. Now, how much distance it has moved? This is the stroke. Total distance moved by the tool will be 2s. Total distance moved by the tool will be 2s. So, please understand all this information. For cycle time, crank will rotate by 360 degree, and in one cycle time, how much distance moved by the tool? 2s. From here to here, from extreme distance between the extreme ends will be the stroke length. Fine. Now, when actual punching happens, actual punching time will be represented by TA, right? So crank will rotate, crank rotation will be theta 1 minus theta 2. Okay. So just take the difference theta 2 minus theta 1. Whatever the angle turned by the crank for that particular punching only. And whatever the distance moved by the tool, how much distance tool is going to move? Tell me. That is what the plate thickness, T. Right? Plate thickness, T. So that's why you need to relate all the parameters. Very important. Cycle time, crank rotation and the stroke length. Actual punching time, crank rotation, plate thickness. Because for actual punching, tool is going to move up to this distance, plate thickness only. Distance moved by the tool during actual punching will be plate thickness. Angle turned by the crank will be theta 2 minus theta 1. Okay, and in the case of complete cycle time, how much distance moved by the tool from here to here and from here to here. That's why 2s I've mentioned there. This much information is clear to everyone. Is this information is clear to everyone? Please tell me, everyone. Okay. Because if you have understood this part, then we can move further here, because this is very basic fundamental part. Without this, we can't move further. Done? Okay. Now, using this relations, I can write one relation here. Everyone, please see. TC divided by TA will be equals to this crank rotation 360 degree divided by theta 2 minus theta 1 equals to 2s divided by plate thickness T. This is the relation. Okay. And whatever the unknown is there, we can easily calculate from this one. Clear? Is this point clear, everyone? Okay, fine. Now, next part that we need to understand here is fluctuation of energy, that is delta E. It is equals to energy required per hole minus energy required per hole minus energy, okay, energy required per hole minus energy available during punching. Is this point clear, everyone? Is this point clear? Energy available during punching, and this is energy required per hole, right? So if I take the difference, I will get the fluctuation in energy. Now, individually, I need to know like how I will calculate energy required per hole and energy available during punching. So one by one, we will discuss this part also. Energy required per hole will be equals to power of motor multiplied by TC, the cycle time. During the cycle time, whatever total time it is taken here, that I've told you, the cycle time, total time taken by the tool. So that time if I multiply with the power motor, so I will get the total energy that is required to cut a hole or punch a hole basically here. So please understand, starting of tool motion is starting from this point and then reaches here, then again go back. This is what one cycle. During this cycle, how many punches will be there? How many hole this machine is going to punch? Only one hole. So that's why energy required per hole will be equals to power of motor multiplied by cycle time. Only one hole is going to punch with this particular cycle time. So that's why power of motor multiplied by cycle time will give the energy required per hole, energy, because power multiplied by time will be what? Energy only. Now, this is there. Another way of calculating this one is what? Energy. Let's suppose energy they have provided per unit area. That area will be what? Shared area. That is the another way of calculating it. Energy required per hole. Now shared area. So let's suppose this is the disc. This is what part we need to punch. Punching operation is there, no? This is the plate thickness. Die of hole. So clear, everyone? So like this. So area, shared area will be pi dh into t. This is there. Now what is energy available during punching? Energy available during punching will be power of motor multiplied by the actual time. Okay. So let us write energy available. Energy available during punching will be simply power of motor multiplied by actual time. So this is the formula we are going to use. Is it clear? How to calculate the fluctuation of energy and how to calculate this individual energy part also. Energy available during punching, energy required per hole, how to calculate energy required per hole, how to calculate energy available during punching, all those parameters should be clear, right? And this relation. With this much information, you can solve any of the problem from the punching. Okay, any of the problem you can solve. So we will discuss one by one some of the questions that was asked in engineering services. Some of the questions we are going to discuss from the engineering services, right? Is that clear? So like this theoretical part, at least if this much, if you have understood and this part, then everything is okay and we can discuss the numericals now after this. Tell me, is it clear everyone? Okay, we'll move to the problem here. Everyone, please see. Now, this was the problem which was asked in engineering services conventional examination. Right? Now, see, carefully read this question. A press has to punch 30 holes per minute. So, line by line, we will read the question and try to understand what actually they are saying. Has to punch 30 holes per minute. Clear? 30 holes per minute. So, if I try to simplify this information, minute means 60 seconds. If I simplify it, it will be 1 by 2. So 1 by 2. So basically I can understand from this information is, in order to punch one hole, how much time is required? 2 seconds. In order to punch one hole, what is the time required? 2 seconds. Time required is 2 seconds. So that 2 seconds is nothing but our cycle time only. This is the cycle time. Okay, they have not given directly, but whatever this information they have provided, from this I can figure out the cycle time also. I figure out basically the cycle time, 30 holes per minute. 30 holes per minute means what? 30 holes divided by 60 seconds and one hole 2 seconds. So for punching one hole, 2 seconds is required. Okay, this is clear. So cycle time is clear. If the actual punching of each hole accomplished during 30 degree of crank rotation of the punching machine. So for actual punching, 30 degree rotation happened in the crank. So theta 2 minus theta 1 information is also clear. Okay. And fluctuation of speed is not to exceed plus minus 10%. So CS value plus minus 10%. Plus minus 10% they have given. Okay, fine. Determine the minimum moment of inertia of flywheel. Determine the minimum moment of inertia of the flywheel which is directly mounted on the crankshaft. Neglect the inertia of the other part. Okay, only flywheel moment of inertia we are going to consider. But actually there will be the moment of inertia of the shaft also. But generally when we are installing or mounting the flywheel on the shaft, we will consider the flywheel moment of inertia only. But in general, you should understand, whenever flywheel is mounted on the shaft, actually what happens, it increases the moment of inertia of the system. It provides the additional moment of inertia, right? Mass moment of inertia. Okay, please understand here, because in rotation we talk about mass moment of inertia. In case of bending, we will talk about area moment of inertia. Both are completely different. Fine. Is this information is clear everyone? So this is what the data they have provided. power of motor is given as 1.5 kilowatt. Okay, fine. Now, with this data, we will be able to find out the actual time also. See how. Just now we have written this relation Tc by Ta equals to 360 degree divided by theta 2 minus theta 1. Right. So, cycle time is 2 seconds. Ta value, actual time we want to calculate. This is 360 and here it is 30 degree. Right. They have mentioned 30 degree of crank rotation. Is that clear, everyone? So, if you solve here, Ta value will be 2 into 30 divided by 360. So, this 0 will get cancelled out. It will be actual punching time will be 1 by 6 second. So, cycle time was 2 seconds and actual punching time is cycle time. Please understand, cycle time is 2 seconds and actual punching time we have solved is 1 by 6 second. 1 by 6 second it is there. Okay, is it clear, everyone? Now coming to the part ki we need to calculate moment of inertia value. Again, in order to calculate moment of inertia value, we have this formula. IM omega square into CS. IM mass moment of inertia multiplied by omega square into CS. This is the formula we are having. Okay. Now please understand, very important point, delta E. So just now we have discussed the approach how to calculate delta E. See, energy required per hole minus energy available during punching. This is the formula. Energy required per hole, either I can use this relation or this relation. Obviously I will use this relation because power of motor is given. Again, energy available during punching, power of motor multiplied by actual punching time. All the values we are having. Okay, power of motor given and actual time we have already calculated. So delta E formula. Energy required per hole minus energy available during punching. Energy available during punching. Is that clear? Okay. Now energy required per hole. Okay, energy required per hole. Power of motor multiplied by cycle time. Power of motor given in the question is 1.5 kilowatt. Cycle time was 2 seconds. Cycle time was 2 seconds. Fine. So from this we will get as 3 kilojoule. Done. So 3 kilojoule will be the energy required per hole. Now energy available during punching. Energy available during punching. Okay. So here power of motor multiplied by actual punching time. Power of motor. Power of motor again 1.5 kilowatt multiplied by 1 by 6 was the actual punching time. From here I will get the answer of energy available during punching also. Now using this values I will put it here. I will get the delta E value also. So please everyone calculate the delta E value and please mention in the live chat box. Okay. That delta E value again I will use here and I will be able to calculate the mass moment of inertia. Now the point is omega average. How to calculate omega average? See, the crank rotation happens we know the complete rotation is 360 degree, right? And for that, whatever time required is, what is the time required? 2 seconds. That is a cycle time, right? So omega average. Angular rotation was 2 pi and time taken is 2. So pi radian per second is the omega average. And what about the CS? Plus minus 10%, so it will be 20%. .2 is the CS value. Finally, delta E answer. If you put all these values, delta E answer in joule you should tell, okay, because this is the kilojoule I have mentioned here. In terms of joule you need to mention it. What will be the answer of delta E? Fluctuation of energy. Write down fast everyone. Approximately it will be 2750. And I will equate with this part. Is that clear? Fine. So mass moment of inertia value you will be getting like this. Fine. So this was the question asked in the engineering services conventional, right? So we have understood how to implement this concept part that we have understood here in the punching. We have understood how it happens, how the punching operation happens here, and what is the role of flywheel here. Okay, because during actual punching only most of the energy is required. Okay, so what happens? Flywheel is going to store the energy whenever it is not performing any work. That is during the ideal motion, when it is not actually doing any useful work, at that time the energy is going to stored in the flywheel, and at the time of punching it will deliver it. Okay, it will return back all those energy it has stored. Energy is stored in the form of kinetic energy, rotational kinetic energy. Okay, so that's why there is a very important role of flywheel in the case of punching machines. Apart from IC engine, most common application is the IC engine, but in the punching machine also there is a role of flywheel. So this relation is very, very important, guys, because cycle time they will give you either directly or indirectly. Actual time we can calculate using this relation. Actual punching time we can calculate using this relation very easily. And after that, this fluctuation of energy, that is delta E, which is energy required per hole minus energy available during punching. This information I can use. Okay, and this there are two ways to calculate energy required per hole. Using power of motor or this directly sheared area. So this energy will be given to us in the question only. And then energy available during punching, this formula is there. And sheared area, okay, like this. So we have understood how to use this information to calculate the answer here, right? So that's all in the flywheel topic, guys. If you have any doubt, any confusion, please do comment, okay? If you are watching this as a recording in the later part, for those students, I want to tell you, if you have any confusion in understanding in any of the topics, please mention in the comment box. I will bring one lecture on that particular topic. Okay, on your demand, we can bring the lectures also. So if you want us to continue this foundation course, and also if you want certain topics to be discussed in the class, so please mention in the comment box. We will definitely discuss those topics also in the live class. Okay, so this is the end of this flywheel chapter, guys. So just for those students who have joined today only, for them I want to tell you, we have started with the simple mechanism. We have discussed the basic fundamental thing, that what is kinematic link, what is kinematic joint, what is kinematic chain, inversions we have seen, single slider crank mechanism we have seen, 4-bar mechanism we have seen, Greshov's law, degree of freedom of the mechanisms, right? So many things we have covered. Then velocity analysis. In velocity analysis, two methods we have discussed. velocity diagram approach and the eye center approach, where we will use the angular velocity ratio theorem. After that, acceleration analysis, right? And then kinematic and dynamic analysis of single slider crank mechanisms we have discussed. After that, this flywheel started. So this is the lecture number 17. Okay, in total 17 lectures we have completed. If you have not started this theory of machine topic, guys, please go back and see the playlist of theory of machine in our channel, and please start from the lecture 1. If you have not started this theory of machine, please start from the lecture 1, because all those fundamental part we have discussed in the initial lectures. Because without those fundamentals, it is very difficult for you to understand theory of machine subject. And I am telling you, if you have understood those basic fundamentals, then theory of machine will be the most interesting subject for you, and also scoring one also. So students who are facing in theory of machine, the problem is they have not understood the basic part. Fundamental part they have missed and directly jump to the advanced topics. That's why they will face the problems. So that's why I'm telling you guys, if you are attending this session today only, like this is the first lecture you have seen, so go back, open the theory of machine playlist in our YouTube channel and start from the lecture 1. No need to create any notes. All the notes are available in the Telegram group channel, and the link of that Telegram group is already available in the description. All lecture PDF you will be getting there. Just try to understand all those basics. No need to write any theoretical things. Everything is available. Just you need to listen the content part very carefully. Right? So I hope you have enjoyed the lecture, guys. And the upcoming sessions we are going to start with gears topic. Very, very important for the GATE examination. Okay, guys. Thank you so much. Please share this session with your friend also, so that they can also start their preparation for this subject, theory of machine. Thank you so much. Bye-bye.